Okay, the last time we went over the study guide, we were able to finish the first 45 questions, and now I'm going to do the rest of them. I don't know if we did 45, but I'm going to do it. Using the frequency distribution to the right, which shows the number of voters in million according to age, to find the probability that a voter chosen at random is in the given age range, not between 18 and 18 and 20 years old. Here's how we do this one. So we want someone who is not between 18 to 20 years old. So our answer, we're going to use the classical definition of probability, number of favorable outcomes divided by number of possible outcomes. So what you're going to do here, we're going to put all the possible outcomes here in the denominator. And the possible outcomes, guys, is that you have to add all the frequencies right here. 5.5 plus 10.3 plus 23.1 plus 23.7 plus 53.2 plus 27.6. So let's add them up. So if you add them up, you get 143.4. This is gonna go in the denominator. Now what goes in the numerator? The favorable outcomes. What are the favorable outcomes? Are anyone who is not between the age of 18 and 20. Let me bring the calculator back. So we need everybody except for the ones who are between the age of 18 to 20. So you can actually do 143.4 minus the ones who are between the age of 18 and 20, which is 5.5, equals. So what you should have in the numerator, we're gonna put, you're not gonna put a fraction as an answer. You have to compute the answer because he says round to 3 decimal places as needed. So it will be, just 1 second, it's giving me a hard time here. What did we get on the calculator? 137.9. So it will be, let me just do it, 137.9 divided by 143.4. You can use your calculator to divide the two numbers. So divide by 143.4 equals, and you need to round it to 3 decimal places, so that will be 0.962. So actually, instead of the fraction, you need to put 0.962, 0.962, and that should be the answer. Okay, let's go to next question. Use a diagram to the right to answer the question. What's the probability that a registered voter did not vote in the election? Okay, so it's a numerator and a denominator. Again, the denominator is all voters, and the numerator is the ones that work in our favor, the ones who did not vote in the election. So we have 3,088,518 who voted in the election, so we just write it down. Again, I'm just showing you the work. You can do your work in your calculator and just put the answer here. All we need is just to put the answer. Now, what goes in the denominator? In the denominator, we need everybody. Now, we have 3,088,518 who didn't vote, who voted. Did not vote. So I was wrong here. So we should put 3 million. Let me just go back. Put the fraction there. It's a 3,316,302, and then what goes in the bottom is the total. So you just add those two numbers, 88,518 plus 3,316 302. And how would you do that on your calculator? Let me bring the calculator up, and it will be let me show you how to do it in one shot. 3316302 divided by, open parentheses because we're adding two quantities at the bottom, so 3088518 plus 3316302, and close parentheses here. You'll get the answer. Round it to 3 decimal places. It's gonna be 0.518. And so you just go back right here and clear everything. Again, the work, you do it on your calculator, don't do it on this screen. And then so it will be 0. Whatever the answer we came up with. Let's go to the next question. Use the bar graph below, which shows the highest level of education received by an employee of a company, to find the probability that the highest level of education for an employee chosen at random is A. Again, definition of probability: favorable outcomes divided by all possible outcomes. Well, he made it easy on you here. So you see how many in A, how many in B. Just add them up. 9 plus 26 is 35, and 33 is 68, 78 and 7 85, and 6 91, and 1 92. So the bottom is 92, and we want the probability of getting an A. How many are in A? 9. So the answer will be 9, and then divided by 92. Use your calculator to divide 9 by 92, and that should be the answer. Okay, he says round the answer to the nearest thousand, so 3 decimal places, so it will be 0.098. Very important to round it properly, guys. So 0.098, and then you go move to the next question. What's the difference between an outcome and an event? An outcome is the result of a single probability experiment. An event is set of all possible outcomes. No, the set of all possible outcomes is called the sample space. An event is a result of a single probability. That's not true. An outcome is a result of a single probability. For example, when you roll a die, you get 6 outcomes: 1, 2, 3, 4, 5, 6. An event, let's say I would win if I get an even number, so your event will have 2, 4, and 6. An event is the result of a single probability. An outcome is a set of all possible events. That's not true. So that's the one. C will be the correct answer. What's the difference between independent and dependent events? 2 events are called independent if the probability of the first event does not affect the probability of the second event. So let's see which one has this definition. That's not true, the first one. When the occurrence of one event does not affect the probability of occurrence of the other events. When the occurrence of one event affects the probability, so that should be B. That's the definition that you learned. The accompanying table shows the numbers of male and female students in a particular country who receives a bachelor degree in business in recent year. Complete parts. That's a very important question, guys. Very, very important question. So you have the table, contingency table, and let me show you how to use the table to answer questions. Find the probability that a randomly selected student is male, given that the students received a business degree. This is a conditional probability, and remember, when you see a given, what comes after given, it's going to be your denominator. So let me just put the fraction and show you how I'm going to set up the answer. So your denominator is going to be the total of all people who receive a business degree, which is what? 360,139. Now what goes in the numerator? That's easy. Look at the male event and look at the business event and see where the two meet together. So it's going to be male watch, male and business. How many? 194,865. 194,865. And then if I go there, the total will be, again, what comes after giving will be your denominator, which is business, total of all business. So it will be 360, 139. Just do the division and round your answer, and you should get the correct answer. Find the probability that the randomly selected students received a business degree given that the student is female. Okay, let's set up the denominator, fraction. Okay, given that student is female, my denominator is all female students. So female, how many? What's the total of all female? 1,096,860. That's going to go in the denominator. What goes in the numerator? What goes in the numerator? Intersection of the two events, female and received a business degree. So business degree and female, which is what? 165,274. And then divided by 1,096,860. Divide the two numbers, get the answer rounded to 3 decimal places, and you should be all set. Decide whether the events shown in the accompanying Venn diagram are mutually exclusive. Two events are mutually exclusive if they cannot happen at the same time. Well, you can see there is an intersection, so it is possible that the two events happen at the same time. So the events are not mutually exclusive since there is at least one presidential who lost the state of, the first state is presidential candidate who lost the state of Montana, the other one presidential candidate who lost the election. So there is at least one president candidate who lost the state of Montana and lost the election at the same time. Because there is an intersection, that means there could be someone who is in the blue and in the pink at the same time. That's what not mutually exclusive means. All right. Determine whether the following events are mutually exclusive. Explain your reasoning. Randomly selecting a male history major and randomly selected a history major who is 21 years old. Is it possible to select a male history major who is 20 years old? Yes. So then the events are not mutually exclusive, since it is possible to select a male history major who is 20 years old. Another one, so you see there's 3 of them, these are important. Randomly selected a voter who legally voted for the president in Pennsylvania, and randomly selected a voter who legally voted for the president in California. Well, that cannot happen. You can only vote once, either in Pennsylvania or California. So the events are mutually exclusive, since it is not possible to both. Illegally, it is possible for a voter to both have legally voted for the president in Pennsylvania and have legally voted for the president in California. Cannot do it at the same time. If you're registered in Michigan, you must vote in Michigan only. Okay, the accompanying table shows in a certain region who receives bachelor degree in a certain field, and a student is selected at random. Find the probability of the event. Okay, here's another example that tells you how important those questions are. What's the probability that students is male or received a degree in the field? Or, this is called the addition rule. So let me show you how we're gonna work out this event. So the probability of a student's male or received a degree, it's going to be the probability of male plus the probability of received a degree minus the probability of male and received a degree, the intersection. So how do you set this up? Let's do the probability of male first. What is the probability of selecting someone who is male? What's the total of male? 753,595 divided by total, the grand total, which is what? 1,728,306. Tab plus Now the probability of mail or received a degree. Degrees in the field. What's the grand total? 326,000. So we're going to put it there. 210. Divided by the grand total, which is 1728306. Tab. Minus, that's the formula, addition rule. The probability of mail and received a degree. Mail, watch guys, and received a degree. Where do they meet? At 177, as you can see the mouse hovering over. So I'm going to just put the fraction here. 177, 688, tab, grand total. 1728306. How would I use the calculator to do this? This is how I would do it if I were you. I just do the numerators only and divide by the denominator. So 7, 5, oops, sorry. That's clear. 7, 5, 3, 595 plus 326 210 minus 177,688, and then I divide this answer by the grand total, which is 1728306, and you get this answer. And rounded to 3 decimal places, your answer is 0.522. That would be the answer. Okay. Let's see what the next question is. What's the probability of students is female or received a degree outside of the field? So it's going to be pretty much the same thing, guys. The first one is what's the probability of getting a female, which is 974,711. Divided by the grand total, which is 1728, that doesn't change, 306. Plus probability of receiving a degree outside of the field. How many received a degree outside of the field? I have 1,402,096. Again, divided by the grand total, which is 1728. There is no conditional probability here. Didn't say giving. Minus the probability of a female and received a degree outside of the field. Where do they meet? Watch, guys. There's the mouse here and degree outside. They meet at 826,189. So fraction 826,189 divide by 1,728,306. And then you just add the numerators, subtract, and then divide by the grand total. You should get the answer. The student is not female or received degree outside of the field. Well, is not female, guys, means male. So it's male or received a degree outside of the field. So you do a probability of male plus probability of degree outside of the female minus the probability of male and degree outside of the field, which is going to be 575909, and you get the answer. Okay. Determine whether a statement below is true or false. If it is false, rewrite it as a combination is an ordered arrangement of objects. Combination is order is not important, guys. Permutation is an ordered arrangement of object. Yeah. That's it. The statement is false. A true statement would be a combination is a distinguishable arrangements of objects. Or a combination is an order around, let me see here. Yeah. Oh, it's not the combination that is an order arrangement of objects. It's the permutation. So, oh, he wants us to correct this word. So it's not a combination. As I said, permutation is an order arrangement of objects. Evaluate the given expression. Let's bring the calculator here. And I showed you before how to do that. So 20 CT, 20, in how many ways you can choose? 2 people from a group of 20 people. So you just put 20 on the home screen. You go to math. You go to probability, you go to NCR, and you get 2, and press enter, and here you go. That's the answer, 190. How do you do this one? Let me show you again the calculator. First of all, you would do 9C3, so you put 9 on the home screen, math, three. Okay, 84. Remember this answer. Now we're gonna do 13C3. So you put 13 on the home screen, math. $286. So it's 84 divided by 286. Okay, he says nearest thousands, 3 decimal places, it will be 0.294. Okay, oh, already I see the answer because I'm showing the answers. Okay, next one. Decide if the situation involves permutation or a combination, or neither. The number of ways a 5-number committee can be chosen from 14 people. Since the order is not important, we just need 5 people. It's a combination. The order doesn't matter. Next one, 59. Translate the following verbal phrase into mathematical expression. The number of empty seats on the plane is at most 19. At most 19, guys, means less than or equal to 19. So you can see that here. And the next one. Translate the following verbal phrase into a mathematical expression. The number of pictures in a box is greater than 65. This is greater than 65. So that ends the study guide. You already have a part 1, and this is part 2.